Now let's look at figure 15-11B and perform the calculation of the previous diagram that we just reviewed with the loads that that feeder was supplying in that sub panel. Now, step one, we're going to apply and calculate sizing the feeder overcurrent device based upon the ampacity of the conductors. Now, make note of that. And notice 215.2A1A, table 430.248, 220.50, and 430.63 is applicable here. And notice the lighting load. It's continuous, so 40 amps times 125% is 50. The receptacle load is already, demand's been applied to it, and it's 37.5 at 100%, non-continuous. The appliance load, though, is continuous, as we saw. 30 amps times 125%, 37.5. The heating load of the air conditioner, we select the largest, so the heat is the largest. So if we take 10 kW times 1,000 times 100% divided by 240 volt, we come up with 42 amps, as the code tells us to do in 220.15. The motor load now, from 430.248, we have a 5 horse, 28 amps at 100%, 28. The same 5 horse at 28 at 100%, 28. The single phase now motor is 16 amps, I believe, at 120 volts times 100%, 16. The 2 horse at 240 volt is 24 amps times 100%. Now, the largest motor that we have here, if you look at it, is 28 amp. So we take 25% of it, we come up with 7. Now, as a person doing the calculations, yes, you could take one of those 5 horse at 28 times 125%, and you wouldn't apply the 25%. So people say, why are you doing that, Jim? Well, the main reason that I am, because you're picking up the largest motor only one time this way. You don't get a little confused and add it in maybe twice. So when we total, the motor load is 270. Now, step 2, 310.14A3, informational note 2, and table 310.16, we've done our math accordingly. We select a 300 kc mill in the 75-degree column that will take care of 270 amps. Step 3, 215.3, 240.4B, 430.63, along with table 240.6A. The 300 kc mill is 285 amps. If we round up to 300 amps, it takes care of the calculated load in step 1 of 270, and it also protects the conductor at 285. So the solution is correct. The size overcurrent protection device, based upon conductor calculation now of load, is 300 amp overcurrent protection device for the conductors. And then the note says, if the largest overcurrent device for any motor of the group is calculated and added to the remaining loads, the same overcurrent protection device produced in step 3 would be used. Now, sometimes designers fail to do this, where it's engineers, electricians, contractors who may be doing this. But they fail to size the overcurrent device based upon the largest motor, say, of the group. You got to run 2 calculations here. So calculating the loads based upon the overcurrent device instead of the conductor ampacity calculated, 215.3 and table 230.48. Well, we just bring the lighting load over at 50 amps, the receptacle load at 37, the appliance load at 37.5. We bring the 42 amps over for the heating load. The motor load now is going to be different. We're going to calculate this motor load different than we did in the calculation for the load for the conductors. Notice 5 horsepower is your largest motor. So we're applying 430.62A. And we take 28 amps from table 430.252 and 250%. And we come up with 70 amp. The 28 amps, you got from your table 430.248. 5 horse at 28, 100%, 28. 1 horse there at 16, 100%, 16. The 2 horse at 24 at 100%, 24. Add those together, 305. Now make note of this. There is no exception in 430.62A to let you go up. You can't round up, so you round down to 300. What did you get over here? Based upon the calculation, the size of the conductors and the conductor size, 300. Most every time, it's going to come out that way. But where you can get messed up is where you have a larger motor than 5 horsepower. You get a larger motor, then the overcurrent device for the motor load may produce the largest overcurrent device, and that's what this figure 15-11B is illustrating.